Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, we're looking for numbers that multiply to give you 12, negative 12, and add to give you a 4. So we have 1 and 12, which if you add or subtract are never going to give you a 4. You also have 2 and 6, which if you subtracted those would give you 4. And you have 3 and 4, which if you add or subtract do not give you 4. So we know we're going to want to use 2 and 6. So we could go ahead and put in 2 and 6. And then we know that 1 is positive and 1 is negative from that negative sign. They tell us it's a positive 4. So that means that our larger number has to be positive. So the 6 is going to be positive, and then the 2 is going to be negative. And so that would be your answer for the factoring. Now for the math knowledge question. The sum of the positive odd integers less than 50 is subtracted from the sum of positive even integers less than or equal to 50. What is the resulting difference? So our positive odd integers are going to be 1, 3, 5, 7, all the way to 49. And then our even integers, I'm actually going to write above these. It's going to be 0, which isn't going to change your sum. 2, 4, 6, 8, all the way to 50, because it says or equal to 50. And it wants to know what is the resulting difference. Well, if we line these all up, we can say 2 minus 1, that would be 1. 3 minus 1 would be 1. 6 minus 5 would be 1, etc. All the way here, 50 minus 49 would be 1. And so every pair is going to give us a difference of 1. How many pairs do we have from 0 to 50? You should have 25 pairs because you have 50 numbers. And so each pair produces 1 difference. So we're going to have a total of 25 difference. You don't have to actually do the whole thing on the calculator, and if you did that, it's not wrong, it's just on the ACT you don't have time to go and do that on your calculator. So you want to think about it mathematically instead of just trying to do it by algebra with your calculator. Alright, so we're looking at lesson 3 today. We're going to be looking at angles. So hopefully after this lesson you will understand more about angles. We're going to start off with a ray. A ray is part of a line that starts in an endpoint and it extends indefinitely in only one direction. The notation, you always start with the endpoint. So on this one, the endpoint is A, and then you name another point on the ray. So B is the only other one. And the notation looks like that. That tells you this is a ray. Now if we have one going this way, I'm going to say A, B here. The endpoint is still A, so we still have to start with A, and then the other point on the ray is B. And so you do ray A, B. Now if we had a point C here, we could label it AC. But if we did BC, ray BC would start at B and go through C. So you have to be careful which point you start with. Opposite rays are just two rays that have a common endpoint and they form a line. So we have ray YX and ray YZ. And together they form the line XY or XZ or YZ, whatever you want to name that as. For an angle, that is a figure formed by two rays with a common endpoint. So we have a ray here, BA, and then we have the ray BC. And together they make up the endpoint. So how can we name this angle here? Well, there are a bunch of different ways we can name it. We can name it as angle. This is the symbol for angle. It looks a little bit more like this actually, but angle 1. We could also name it as angle B, because B is the point that is at the vertex. This is called the vertex, where the angle actually starts turning. We could also name it as angle A, B, C. So if you start here and go around, you'd go A, B to C. Or you can name it as angle C, B, A. Because if you go the other direction, starting at C, you go C, B, A. Those are the 4 ways you could name it. You could not name it as angle B, C, A. If I did B, C, A, B to C to A would be that point. That angle. So the vertex angle has to be the point that's in the middle. Okay? So I was referring to vertex already. The vertex is the common endpoint of the 2 sides of the angle. So this is our vertex right here, because that's where the 2 rays meet up. And then the rays are the sides of the angles. So here's one ray, and here's the other ray. Now we're going to look at interior versus exterior. You've probably heard those terms. The exterior is all of the points that are outside of the angle, and the interior is all of the points that are inside, in between the sides of the angle. So the exterior of the building is the outside. You are currently on the interior of the building because you're inside of the building. Okay? So now we're going to look here. Name 3 rays in the diagram. 1 ray could be from Y to F. So ray Y, F. And that's the only way that you could name that one. You can't name it FY. Another ray would be YG. And that's the only way that you would be able to name this ray here. Another ray would be YH. And that would be this one here. And that's the only way that you can name that ray. You could also name FG. That could be a ray. Or you could name FH. That's the same ray as FG. It just keeps going, but FG keeps going, and so it would eventually hit H. And so you could name it that way. You could name ray GH. And so that ray would be starting here and going this direction. So that could be a ray. You could also name HG as a ray, and that would be going this direction. The same ray would be HF, and so you could name it that way. And then another one that would look different from the 2 that I just did would be GF, and it would have to start at G. So it said pick 3 of them. Those are the only 9 that I can come up with. But hopefully you would pick 3 of those 9. So when it says pick 3, I really don't want you to put more than 3, because if that 4th one is wrong, then I'm going to have to mark your answer wrong. So just pick 3 of them, but I just wanted to make sure y'all had the concept down. Okay, for 3 angles in the diagram. 1 angle, I could name this one here. So do you see how there's actually another angle over here, and over here, and here? Since there are multiple angles at F, you don't want to just use F. So we need to use 3 letters, 3 variables. So angle YFG would be 1 angle here. If we wanted to pick this angle up here, do you see how there are multiple angles? You're going to want to pick 3 letters. So HYG. I could also pick this angle here. That would be angle YGH. So there are lots of angles that you could pick there. 1, 2, 3, 4, 5, 6. I think I count 7 that you can pick. And then you could name each of those 7 by flipping these 2 points that are on the outside. So technically you could have 14 different ways to write your answers. You would pick 3 of those. So if y'all want to pause the video and check with your neighbor to make sure that another angle that you named would work, that is fine. Okay, what is another name for FYH? Well, the easiest thing to do for an angle is to make it HYF. And so that would be just switching the 2 on the outside. The Y has to stay in the middle because it's the vertex. So this is what the angle symbol looks like in actuality. Y'all may have seen that before. It looks a little bit different than what I write out by hand sometimes. Hopefully those help you for that example. So now we're going to look at some protractors. If you look in your box, you have a protractor. It's just a tool that you use to measure angles, and your angles are always measured in degrees. So we're going to look at postulate number 3, the protractor postulate. So it says, given a point X on a line PR, consider rays XP and XR, as well as all the other rays that can be drawn with X as one endpoint. These rays can be paired with the numbers 0 to 180, such that XP is 0 and XR is 180. So I'm going to draw this out real quick. PR, and it says XP is 0 and XR is 180. And then A is somewhere in between these. So I'm going to put A up here. This angle here you can find with a protractor. Or if we put it over here, we can find the angle here with a protractor. And that's all it's saying. That the angle is just the difference between the 2 numbers. So that's your protractor postulate. It's basically a bunch of words for something that's not terribly difficult. So these you should be familiar with. We're just going to go over them very, very quickly. An acute angle measures more than 0 but less than 90. Obtuse angle is more than 90 but less than 180. A right angle is exactly 90 degrees, and then a straight angle is exactly 180 degrees. So hopefully all of those are familiar to you. So now we're going to use a protractor, and you need to get out your book. So we're going to go to page 15 in the textbook to use a protractor to measure angles ABC, angle DEF, and angle GHI. Alright, so once y'all are looking at page 15 in the book, you need a protractor, so pull it out of your box, and I'm going to go over how you use a protractor. So this is copied from the book. You have a line here at the bottom, and y'all's has more plastic at the bottom, but there's a black line that you're going to want to set on this BC. And then there's going to be a straight line here that you're going to want to put on B. And so some of them have a hole, but you want to make it look like that, basically. And then from C, we're going to go over to A here. And so if we start, you see how there's 0 and 80 and 10 and 170? We're going to start with the 0 number, and then we're going to 50, 60. As you keep going around, you should get to 130. And so the angle measurement of ABC would be 130 degrees. So if you get this accurate, then it should show 130. If it looks like it's 129.5, don't put 129.5. They usually give you whole numbers. So don't try and make this more precise than it needs to be. Okay? But that's how you can use your protractor. Let's look at the next one. Now, again, you're going to put that line on EF, and you're going to put the little dot at E. And y'all may be having a little bit of a trouble because your DE isn't going out far enough. So I'm going to make it do that on this one. I'm going to make it too big, which my protractor still gives me little lines here, which yours does not. So take a piece of paper and put it on ED. Let's see if I can draw it out. Put your little piece of, it's not going to let me draw on it, but put your little piece of paper here and use the edge of the paper to extend DE out. And if you do that, it'll help you to know where exactly it keeps going. Because sometimes they draw the pictures too small to use your protractors like you would like to. But if you look, we start with the 0 number and we go up to 40. So that's how that would work. Okay, let's look at this last one. So I got to turn my protractor around. So you can turn it this way or you can turn it this way. Either one of them is fine. But you put the line on HG and then the little dot goes on H. And if you look, it's a 90-degree angle. So that's how you can find your angles using protractors. So now it says use a protractor to measure them and classify. So if this was 130 degrees, what kind of angle would it be? Well, it's going to be an obtuse angle because it was greater than 90 but less than 180. For this 40-degree angle, it is going to be an acute angle. And then for this 90-degree angle, that would be a right angle. So hopefully that helps you with protractors. If y'all need to pause the video and go over it with your neighbor, that's fine. It is kind of hard to show and explain from a video how to use a protractor. Okay, so now we're going to look at the angle addition postulate. This is postulate number 4. This is kind of related to the segment addition postulate. So if point D is on the interior of our angle ABC, then the measure of angle ABD, that is this part, plus the measure of angle DBC, that is this part, is going to equal the measure of angle ABC. So these two together make up the whole. Okay, so let's look at an example here. I like to fill in on my picture as best I can. So they tell us that MQP, so that's this whole thing, is 162. And then they tell us that NQP, that's this part here, is 52. And they want us to find what is the measure of MQN. Well, the measure of angle MQN plus the 52 degrees has to equal the 162 because these two add up to the bigger one. So that means that the measure of angle MQN has to equal 110 degrees. Okay, so that's how you can use your angle addition postulate. Now we're going to look at bisect. So bisect means to divide a figure into two congruent parts. So an angle bisector is a ray that divides an angle into two congruent angles, and you mark them with arc marks. So if I have an angle, and this is the angle bisector, that means that this one and this one are congruent. And they each have one arc mark, so that's how we know they are congruent. You could also make it have two arc marks. So that's how you can tell they are congruent. For a segment, if this bisects them, that means that it's the midpoint. So a midpoint bisects a segment. Let's look at this example. The measure of angle WXY is 15 degrees. So WXY right here is 15 degrees. And it says that XY bisects WXZ. So that means that these two angles have to be congruent. So if this one's 15, this one over here is 15. And then it tells us the angle UXV is 40 degrees. Well, do y'all see this arc mark here? That means that these two angles are bisected, and so this angle has to be 40 degrees, just like this one. So that's the first thing you want to do, is figure out your angles. And then it says find the measure of y, x, u. Well, what are the two angles that are in that? 15 and 40. So 15 plus 40 would be 55 degrees. Okay? Now we're going to look at this example. So we have a poll surveyed by the favorite type of vegetable. And this is the data they collected. They surveyed 300 people. How many chose carrots? So the first thing that we need to do is use our protractor to measure the angle. So where is this going to go, do y'all think? Hopefully you said at the center. So we need to put that at the center, and then I need to turn it so that one of the edges of carrot is on the end. And so that's what it looks like. And then what does it look like this angle measurement of carrot is? Let's see if it'll let me draw here. I don't think it will. But this angle here, it looks like it's really close to 60. So what did I say? Don't try and estimate, like just estimate it. Don't try and make it an exact number. So we're going to say it's a 60-degree angle. And so how many degrees are in a total circle? There are 360 degrees in the total circle. So 60 out of 360 is 1/6. And so we need 1/6 of the total number of people, which is 300. So a sixth of that would give us 50 people. So that's the number of people that wanted carrots. Okay, so that's how you can do those. So now we're going to look at some practice problems. So y'all try these by yourselves and then unpause the video and I'll go over how to do them. So for part A, there are only 3 rays that are shown. Well, there are more, but it says pick 3. So one of them would be ray ST. One of them could be SP. That would be the ray from here to here. One of them you can name as SR. That would be going from here to here. You could name RS or RP. That would be the ray starting at R and going this direction. Or you could name ray PS and PR. And that would be the ray going this direction. So that would be some of the rays you can name. So pick 3 of them. And then we're going to name some angles. So it says pick 3 angles. And there are only 3 angles really in here. There's this one. So that could be angle RST. There's this one, which would be angle TSP. And then there's the straight angle, which is angle RSP. You could make this angle TSR, angle PST, and angle PSR, but those are the only 3 angles that are in that picture. Alright, for B, if you look in the book on page 16, you're going to need to use the book to do that one. It should be an obtuse angle. You can tell that by looking at it. And it should measure 125 degrees. So if you did not get that, grab a neighbor and y'all go over that one real quick. Y'all may need to pause the video so you can make sure to go over that one. Now we're going to look at C. Determine the measure of angle AEB. So what is this angle if this whole AED is 120? So we don't know the measure of angle AEB, but we know that it plus 22 degrees plus 33 degrees equals 120, because all 3 of those make up the big angle. So if you add 22 plus 33, you're going to get 55 degrees. And then you're going to subtract 55. And that'll give you 65 degrees for your answer. So hopefully you were able to get most of those correct by yourself. We're going to look at 2 more practice problems. So y'all pause the video and try these, and then unpause it and I'll go over them. So it tells us the measure of WXY is 32, and it tells us that XY bisects WXZ. So these two are the same, so that means that this angle over here is 32. And then the measure of angle UXV is 35. And we know that these two angles are congruent because they're bisected, so that means that this angle is 35 degrees as well. And we want to find the measure of angle YXU. So that would equal 32 degrees plus 35 degrees, which is 67 degrees. Okay, now looking at this one. A survey shows that 10% of the students in a class did not eat lunch. What would be the degree measure of an angle on a circle graph? Well, we have 360 degrees in a circle, and so if we did 10% of 360, that would give us 36 degrees. So that would be your answer for this one, 36 degrees. So now we're going to look at our challenge question, and it wants to explain how having a large protractor will affect the measurements of an angle. So y'all pause the video and think about that real quick, and then I'll go over that one. So a larger protractor is not going to affect the measure of your angles. It may make it more difficult to find them just because, like, if you have a small angle, you'll have to extend the side lengths. But it won't make it more difficult. It won't affect the measure. It could just make it more difficult just because you have to extend the lines. But it may make it so that you have a more precise degree measure because it gets it where it's a little bit spread out between one angle measurement to the next. So it may make it more exact. And some people may think it may make it easier because it'll make it more exact. So it doesn't affect the measure of the angles though. Protractors, small ones, big ones, they still give you the same angle measurements for the same angle. It just changes how you may have to go about finding the angle measurement depending on how big the protractor is. Alright, so your homework is 1 through 30, so make sure y'all do those tonight so we can go over any questions you have tomorrow.